Hello everyone, a warm welcome to the next session of machine learning with Python programming. I hope everyone is fine and everyone is learning machine learning with Python programming from my first session to till now. Yeah, and I hope you are enjoying everything. Yeah, so by the way, I hope you remember the session types of machine learning. Yes, so we have seen supervised machine learning, unsupervised machine learning, semi-supervised machine learning, yeah, reinforcement learning. Under supervised machine learning, we have seen the algorithm, regression, and classification. Am I right? Yeah. So under the regression analysis, we have seen simple linear regression, multiple linear regression, polynomial regression. Yeah, we have seen all the theory with its implementation with the help of Python code. Yeah. After that, we have started with the classification. Yeah, so we have seen what is classification and what are the algorithms under it. So in case of classification, we have seen logistic regression, KNN classification algorithm. Yeah, that is K nearest neighbor. After that, we have seen decision tree and support vector machine. So under the classification, we have seen 4 different algorithms. Yeah, with its theory, with its example, with the help of Python programming, with its implementation. Yes. So finally, let's proceed with the next thing. In supervised learning, we have seen regression. Under the regression, we have seen 3 different algorithms. Okay. And in case of a classification, we have seen 4 different algorithms. Yeah. Now it's time to proceed with the next point. Okay. So in case of unsupervised learning, I hope you remember unsupervised learnings are classified into 2 categories of algorithm. Yeah. What are those? Yeah. First one is clustering. Second one is association. Yeah. So in this session, we are going to start with the first point, that is clustering part 1. Okay. And I hope you remember what is clustering. Yeah, we have seen a theory about it while we are discussing the types of machine learning. Yeah. Now let me show you what you are going to learn in this session. So see here, we will see what is clustering, application of clustering. Okay. And then clustering algorithms. Okay. What are the algorithms are there in case of clustering? And then we start with the first algorithm, that is k-mean clustering. Okay, k-means clustering. Next one, we will see how does the k-means clustering works. And finally, we will see the k-means clustering algorithm example. Okay, with its implementation with the help of Python code or Python programming. Got it? So this is our part 1 of clustering. So let's start with the first point. Yeah, what is clustering? So see, as you know that unsupervised learning is the training of the machine using the information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. Here the task of the machine is to group the unsorted information according to the similarities, pattern and differences without any prior training of data. Yeah, I hope you remember this one. Yeah, we also have seen the theory about unsupervised learning. Yeah. Unsupervised learning classified into 2 categories of algorithm. First one is clustering, second one is association. So we are going to focus on clustering. Okay. Clustering is an important concept when it comes to unsupervised learning. It mainly deals with finding a structure or a pattern in a collection of uncategorized data. Yeah. Clustering algorithm will process your data and find natural clusters or groups if they exist in your data. Okay. You can also modify how many clusters your algorithm should identify. It allows you to adjust the granularity of these groups. Clustering is one of the most frequently utilized forms of unsupervised learning. Yeah. So clustering is one of the important concepts when it comes to unsupervised learning. Clustering mainly deals with finding a structure or a pattern in a collection of uncategorized data. Clustering algorithm will process your data and find the natural clusters or groups if they exist in the data. You can also modify how many clusters your algorithm should identify. It allows you to adjust the granularity of these groups. Clustering is one of the most frequently utilized form of unsupervised learning. Yeah. So see here, we have seen that. Suppose this is your data, this is a sample of data, and if you apply the clustering algorithm to it, you will see here the three different objects, the collection of objects, this one, this one, this one. Yeah. Or you can say three different groups are this one. These sample or the collection of data are classified into or groups into three different categories. This one, this one, this one. Yeah. After applying the clustering or grouping, you can say, yeah. Clustering is often used as a data analysis technique for discovering interesting pattern in data, such as groups of customers based on their behavior. Yeah. Clustering is often used as a data analysis technique for discovering interesting patterns in data, such as groups of customers based on their behavior. There are many clustering algorithms to choose from and no single best clustering algorithm for all cases. Instead, it is a good idea to explore a range of clustering algorithms and different configuration for each algorithm. It involves automatically discovering natural grouping in data. Clustering involves automatically discovering the natural grouping in data. Unlike supervised learning, clustering algorithms only interpret the input data and find natural groups or clusters in feature space. Got it? Unlike supervised learning, clustering algorithm only interpret the input data and find natural groups or clusters in feature space. Clustering involves automatically discovering the natural grouping in the data, and it is often used as a data analysis technique for discovering the interesting patterns in data, such as the groups of customers based on their behavior. Okay, and there are many clustering algorithms to choose from, and no single best clustering algorithm for all cases. Yeah. Instead, it is good idea to explore a range of clustering algorithm and different configuration for each algorithm. Yeah. Clustering is a task of dividing the population or data points into number of groups, such that the data point in the same groups are more similar to the other data points in the same group and dissimilar to the data points in other group. Are you getting it? Clustering is a task of dividing the population or data points, or you can say simply data points. Clustering is a task of dividing the data points into number of groups, such that data points in the same groups are more similar to the other data points in the same group and dissimilar to the data points in other groups. Got it? It is basically a collection of objects on the basis of similarity and dissimilarity between them. Yeah, is it simple? So it is basically a collection of the object on the basis of similarity and dissimilarity between them. Yeah. So what does it do? In clustering, the task is, what is the clustering? Clustering is a task of dividing the data points or the collection of the objects into the number of groups, such that the data points in the same groups are more similar to the other data points in the same group and dissimilar to the data points in other groups. It is basically a collection of objects on a basis of similarity and dissimilarity between them. Generally, it is used as a process to find meaningful structure, explanatory underlying processes, generative features, and grouping inherent in a set of examples. Got it? I hope you are understanding what is clustering. Yeah. Clustering technique apply when there is a no class to be predicted, but rather when the instances are to be divided into natural groups. Yeah. Clustering techniques apply when there is a no class to be predicted, but rather when the instances are to be divided into a natural groups. Clustering can be helpful as a data analysis activity in order to learn more about the problem domain, so-called pattern discovery or knowledge discovery. Yeah. So can you see this one in this image? Based on the similarity of the object, it is going to make a groups. Okay. Number of groups. So let's suppose it's a collection of the data points. So based on the similarity of the different objects, okay, it is going to create a grouping for that. So that you can see clearly here, once you apply the clustering algorithm, yeah, to this sample, let's suppose, once you apply the clustering technique to this sample data, you're going to get 3 different groups here. Okay. And each data points in each group, yeah, the data points in same groups are similar to each other, but the data points of this group is different from this group. The data points or the objects from which is present in these groups is different from the objects or data points from this group. Are you getting it? Yeah. So you can say clustering is a task of dividing the data points into a number of groups such that data point in the same groups are more similar to other data point in the same groups and dissimilar to the data points in other groups. Clustering techniques apply when there is a no class to be predicted, but rather when the instances are to be divided into natural groups. Clustering can be helpful as a data analysis activity in order to learn more about the problem domain, so-called pattern discovery or knowledge discovery. A cluster refers to a collection of data points aggregated together because of a certain similarities. What is a cluster? A cluster refers to a collection of data points aggregated together because of a certain similarities. Yeah, getting it? Cluster refer to the collection of data points aggregated together because of certain similarities. Yeah, got it? Now let's see the next point, application of clustering. So I hope you got an understanding of what is clustering. Now let's proceed with the next point, application of clustering. So see here, clustering is a widely used technique in the industry. It is actually being used in almost every domain, ranging from banking to a recommendation engines, document clustering to a image segmentation. Okay. So see here, the first application of clustering is in customer segmentation. One of the most common application of clustering is customer segmentation. Yeah. And it is not just limited to a banking. This strategy is across functions, including the telecom, e-commerce, sports, advertising, sales, etc. By the way, what is customer segmentation? Let's suppose if a bank want to give a loan to a certain customers. On what basis the bank will decide to whom the bank can give the loan or to whom the bank should reject the loan. Yeah. So based on the, you might be thinking based on his salary. Yeah. Based on the salary of the customer. Yeah. Based on his account balance. Yeah. The bank will decide whatever it is. So see, a bank will have a millions of customers. Yeah. So it's not possible for a bank to look at all the customer and decide manually which is a good customer for a loan and which is a not eligible customer for a loan approval. Yeah, or you can say it is not possible for a bank to look at the millions of customer data and decide which customers are eligible for a loan and which are not eligible. So for that, What the bank will do? Bank will do the customer segmentation in such a way that they can group the customers based on the higher salary, medium salary, and low salary. Got it? And then based on the salary and the transaction, they can decide the whether the customer is eligible for a loan or not. Got it? So customer segmentation, one of the most common application of clustering is a customer segmentation. And it is not just limited to banking. This strategy is across functions, including the telecom, e-commerce, sports, advertising, sales, etc. Got it? Yeah. Let's see the next application of clustering, document clustering. This is another common application of clustering. Let's say you have multiple documents and you need to cluster similar documents together. Clustering helps us group these documents such that similar documents are in a same cluster. Yeah. For example, if you have two types of document, first one is your education document, next one is your experience document. Yeah. The industries in which you have worked and you have the work experience with you for each of the industry you have worked. So clustering is going to help us to group these documents into two clusters, or the clustering is going to help us to group these documents into two groups. Yeah, first one is the documents related with your education, and the next one, the document related with your experience, work experience. Yeah. So the most common application of clustering is also document clustering. First one is customer segmentation. Next one is document clustering. Yeah. So clustering helps us group the documents such that similar documents are in the same clusters. Okay. Next application of clustering you can see here, that is image segmentation. We can also use clustering to perform image segmentation. Here we try to club similar pixels in an image together. We can apply clustering to create clusters having similar pixels in the same group. Yeah. We can also use clustering to perform image segmentation. Okay. In this case, what do we do? Here we try to club similar pixels in the image together. We can apply clustering to create clusters having the similar pixel in the same group. Are you getting it? Yeah. Now next application, let's see that. Marketing. Clustering can be used to characterize and discover customer segments for marketing purpose also. Okay. The next application is in biology. It can be used for classification among different species of planets and animals. Yeah. Clustering can be used for classification among different species of plants and animals. Yeah. Next application of clustering is in libraries. It is used in clustering different books on the basis of topics and information. Yeah. So I hope you visit the libraries. Yeah. So in which you will find that the books which is related to the same subject or same topics, they keep in a one cluster, you can say in a one group, whereas the other books which is belong to some other topic, they keep in some other group. Yeah. Let's suppose you have two types of books. First one is the books related with the, assume that biology. So whatever the books are there related with the biology, you will keep it in one group. And let's suppose if you have another book related with the mathematics. So whatever books are there related with the concept of mathematics, you are going to keep it in other group or in other cluster. Yeah. Now next application of clustering is insurance. In insurance, clustering is also used to acknowledge the customers, their policies, and identifying the frauds. That's very important. Yeah. Clustering is used to acknowledge the customers, their policies, and identifying the frauds. Got it? So we have seen some application of clustering. First one is customer segmentation. Next one is, what is the next one? document clustering. Third one is image segmentation. Yeah, this one. Yeah, fourth one is marketing, and then the biology. Yeah, fifth one is in biology, and then sixth one is in the library, and seventh one is in insurance. Okay, so I hope you understand the application of clustering. Yeah, so what is clustering and the application of clustering? Got it? Yeah. Now let's proceed to the next point. Clustering algorithms. Okay, there are many types of clustering algorithms. Many algorithms use a similarity or a distance measured between examples in the feature space in an effort to discover dense regions of observation. As such, it is often good practice to scale the data prior to using clustering algorithm. Some clustering algorithms require you to specify or guess at the number of clusters to discover in the data, whereas others require the specification of some minimum distance between the observations in which example may be considered close or connected. Yeah, so there are various types of clustering algorithm. Each algorithm offers a different approach to the challenge of discovering natural groups in data. There is a no best clustering algorithm and no easy way to find the best algorithm for your data without using control experiment. Yeah. So you cannot say which one is the best algorithm directly. Yeah. So there is a no best clustering algorithm and no easy way to find the best algorithm for your data without using control experiment. There are various types of clustering algorithms such as k-means clustering, hierarchical clustering, means shift clustering, etc. Okay, are you getting it? Each algorithm offers a different approach to the challenge of discovering natural groups in data. There is a no best clustering algorithm and no easy way to find best algorithm for your data without using control experiment. Okay, so based on the data, based on the challenge, based on the problem, you need to choose the best algorithm fit for your problem. Okay, hence you can say that there is a no best clustering algorithm and no easy way to find the best algorithm for your data without using control experiment. There are various types of clustering algorithm such as k-means clustering, hierarchical clustering, mean shift clustering, etc. Okay, here we will cover some of the important clustering algorithms. Okay, so we are going to start with one of the most important type of clustering algorithm, that is k-means clustering. Okay, so before going to start k-means clustering, I hope you got a clear concept about clustering algorithm, and make a note of it that there is a no best clustering algorithm and no easy way to find the best algorithm for your data without using the control experiment. Okay, and there are various types of clustering algorithms such as k-means clustering, hierarchical clustering, mean shift clustering, etc. Okay, so here we will cover some of the important clustering algorithm. Okay, in this part we will start with the most important type of clustering algorithm, that is k-means clustering. Okay, and in our later session we will start with the next type of clustering algorithm. Okay, but as of now we are going to see k-means clustering. Okay, so let's see that. Yeah, k-means clustering. So see here, k-means is considered by many to be the gold standard when it's come to the clustering due to its simplicity and the performance. So it is the first one we will try out. Yeah, you might be thinking why we are understanding k-means clustering algorithm first. Why we are not going with the KNN or some other type of clustering algorithm. Yeah. So see here, K-means is considered by many to be the gold standard when it's come to the clustering due to its simplicity and performance. So it is the first one we will try out. Okay. K-means clustering is one of the simplest and popular unsupervised machine learning algorithm. Yeah, obviously it is unsupervised because clustering falls under the unsupervised machine learning. Yeah. So K-means clustering is one of the simplest and popular unsupervised machine learning algorithm. When you have no idea at what algorithm to use, K-means is usually the first choice. Yeah. When you have no idea at all what algorithms to use, K-means is usually the first choice. Okay. K-means algorithm partition an observation into K clusters where each observation belongs to the cluster with the nearest mean serving as a prototype of the cluster. Okay. K-means algorithm partition an observation into the K clusters where each observations belong to the cluster with the nearest mean serving as a prototype of the cluster. Okay. So I hope now you got why you are first of all learning the K-means clustering. Yeah, because it is considered by many to be the gold standard when it's come to the clustering due to its simplicity and performance. Okay, and it is the first we should try. K-means clustering is one of the simplest and popular unsupervised machine learning algorithm. K-means algorithm, partition, and observation. Yeah, you can see this one n, that is total number of observation, into K clusters or group where each observation belong to the cluster with the nearest mean serving as a prototype of the cluster. Yeah. You will define a target number K which refer to the number of centroid you need in a dataset. A centroid is the imaginary or a real location representing the center of the cluster. What is centroid? Here, in case of a K clustering, you need to define the target number K, which refer to the number of centroid you need in the dataset. Okay, so you need to decide the total number for a K. Okay, and what is this K? It refers to the number of centroid you need to have in the dataset. A centroid is an imaginary or real location representing the center of the cluster. Okay, what is a centroid? It is the imaginary or real location which is representing the center of the cluster. Okay, it is representing the center of the cluster. In other words, the K-means algorithm identifies the K number of centroid and then allocate every data points to the nearest cluster while keeping the centroid as small as possible. Okay, the K-means algorithm identifies the K number of centroid and then allocate every data point to the nearest cluster while keeping the centroid as small as possible. The means, okay, you can see what is the name of the algorithm? K-means clustering. So here, what is this means? The means in a K-means refer to the averaging of the data, that is finding the centroid. And what is the centroid? Centroid is an imaginary or a real location representing the center of the cluster. Okay, so in case of K-means clustering, first of all, you need to define or you need to think the target number K, which refer to the number of centroid. Okay, in other words, the K-mean algorithm identify the number of centroid, that is K, and then allocate every data points to the nearest cluster while keeping the centroid as small as possible. Okay, the means in a K-means refer to the averaging of the data, that is finding the centroid. Got it? Yeah. K-means is a centroid based algorithm or a distance based algorithm where we calculate the distance to assign a point to a cluster. In k-means, each cluster is associated with a centroid. Okay, k-means is a centroid based algorithm or a distance based algorithm where we calculate the distances to assign a point to a cluster or a group. In k-means, each cluster is associated with a centroid. Okay, and what is a centroid? Centroid is a imaginary or real location, okay, representing the center of the cluster. Okay, the main objective of a k-means algorithm is to minimize the sum of distance between the points and their respective cluster centroid. Make a note of it. The main objective of a k-means algorithm is to minimize the sum of the distance between the points and their respective cluster centroid. Make a note of it. So the main objective of k-means clustering algorithm is to minimize the sum of the distance between the points and their respective cluster centroid. Okay. Now let's understand how does the k-means clustering works. Okay. Now let me explain you with the help of examples. So till now you have just seen what is k-means, what is that k in case of k-means clustering, what is mean by this means in case of a k-means clustering, okay, and what is centroid. Yeah, and you can say k-means clustering is a centroid based algorithm or distance based algorithm where we calculate the distance to assign a point to a cluster. Yes, so just now we have now seen the cluster k-means clustering. K-means algorithm partition an observation into k cluster where each observation belongs to the cluster with the nearest mean serving as a prototype of the cluster. Now let's see how does the k-mean clustering work. Okay. Now let's take an example to understand how k-means actually work. Okay. So see here, we have these 8 data points and we want to apply k-means to create clusters for these points. Here is how we do it. So let's start the example. Okay. So what we are doing here? Yeah, we are going to understand how the k-means actually work with the help of example. Okay. So let's suppose we have these 8 points. You can see this one. Yeah, these 8 points. And we want to apply the k-means to create clusters for these points. Okay, we want to apply k-means clustering for creating clusters on these points, for these points. So here's how we do it. Okay, now let me show you the first step for it. Choose the number of clusters, that is k. Okay, first step in a k-means is to pick the number of clusters k. Okay, number of cluster k. Now what is this? By the way, you might be thinking, what is this k? So we have seen this. You will define a target number k, which refer to the number of centroid you need in a data set. A centroid is an imaginary or a real location representing the center of the cluster. So first of all, you need to decide, you need to focus, or you need to choose the number of cluster k. Okay, number of cluster or number of groups. The first step in k-means is to pick the number of cluster k. Okay, now the next step is select k random points from the data as centroids. Okay, so once we have decided the number of cluster, the second step is to select k random points from the data as centroid. Next, we randomly select the centroid for each cluster. Let's say we want to have 2 clusters. Okay, let's assume that the first step is choose the number of clusters. So let's suppose we have 2 clusters. So let's say we want to have 2 clusters. So k is equal to 2 here. We then randomly select the centroid. Okay, first step to select the number of clusters. So let's suppose we have chosen the value for a k is 2. The next step is select the k random points from the data as a centroid. Okay, so what we are doing here, we are randomly selecting the centroid here. So let me show you this one in the image. Can you see this one? This is our second step. First step, we have decided the number of cluster 2. Next step is we need to randomly select any 2 centroid. Okay, so here the red and green circle represent the centroid for these clusters. Okay, so let's suppose this is our first group, this is a second group. Or these are the cluster. How many cluster we have chosen? 2 cluster. Okay, now it's time for us to decide the centroid for it. So let's suppose this C1 is a centroid for this group, C2 is a centroid. Okay, so here the red and green circle represent the centroid for these clusters. How many clusters? 2 clusters. Okay. Now let's see the third step. Are you clear with the first 2 steps? How does the k means clustering work? First of all, decide the number of k, that is clustering. So we have chosen 2 clusters or 2 groups. After that, we need to randomly select the centroid. Yeah. So what is centroid? Centroid represent the real time or imaginary location. Yeah, you can see this one. Centroid is the imaginary or real location representing the center of the circle. It is representing the center of the cluster. Is it correct? Yeah. So we have chosen number of cluster and then we have selected the random points from the data as the centroid. So we have selected these 2 points. So here the red and green circle represent the centroid for these clusters. And as per the definition, what is centroid? Centroid is nothing but a real time or it's an imaginary location that represent the center of the cluster. Is it correct? Yeah, it is the center of the cluster. Make a note of it. A centroid is the imaginary location representing the center of the cluster. Okay. By the way, do you think is it a center of the cluster? So we randomly have chosen 2 clusters, C1 and C2. So you can see here the red and green circle represent the centroid for these clusters. Okay, now let's see the third step. The third step is assign all the points to the clusters to the closest cluster centroid. Assign all the points to the closest cluster centroid. Okay, once we have initialized the centroid, we assign each point to the closest cluster centroid. So see here, in the previous image, you can see this one. There are 2 centroids, C1 and C2. What is the third step? We need to assign each point, assign all the points to the closest cluster centroid. Once we have initialized the centroid, we assign each point to the closest cluster centroid. So see here in this image, obviously this point is nearest to this close. Yeah, this point is nearest to this one, C1. Yeah, so you can assign this one to this one. And obviously this point is also near to this one. This point is also near to this one. So you need to assign all the points to the closest centroid. Yeah. So these 3 points are closest to the centroid. So you can assign these points to the centroid C1. Okay. Now these 2 points look like closest to the centroid, this one. So you can assign all the points to the closest cluster centroid. So C2, so see here, it looks like green, so it's a green. Now you might be thinking about this one. So whether is it close to this C2 or is it close to C1? See here, we need to assign this point to the closest centroid or closest cluster centroid. So if you look at very carefully, so this point, is it nearest to this cluster? Is it nearest to this centroid or this centroid? Yeah, here the red and green circle represent the centroid of the clusters. What is the third step? You need to assign all the points to the closest cluster centroid. Yeah, assign all the points to the closest cluster centroid. So which point is nearest to this centroid? So see, obviously these 3 points are nearest to this centroid. So we need to assign this point to this one. Yeah, so it's a red color, so you can assign all these 3 points to a red color. Okay, if you talk about these 2 points, obviously it's closest to this centroid C2. So assign all the points closest to the cluster centroid. So once we initialize the centroid, we can assign each point to the closest or nearest cluster centroid. So see here, these points look like nearest to this one, C1. So hence you assign this one red color. Okay, it look like a little bit far from C2. So but it look like a little bit nearest from C1. So you have assigned this point to this cluster. Okay, got it? First step is choose the number of cluster. Second step is randomly select the centroid. Okay, for the clusters. Yeah, so we have selected 2 cluster here, C1 and C2. After that, assign all the points. Assign all the points to the closest cluster centroid. So assign the points. We can assign each point to the nearest or closest cluster centroid. Okay, so it looks like there are 5 red points with 3 green points. Now let's see the fourth step. Here you can see that the points which are closer to the red points are assigned to the red cluster. Yes, you can see this one. In this image, you can clearly see this one. The points which is nearest or closest to this centroid C1 are assigned to the red cluster. Yeah, you can see that the points which are closer to the red points are assigned to the red cluster. Yeah, whereas the points which are closer to the green point are assigned to the green cluster. Is it correct? So these 2 points are nearest or closest to this centroid C2. Hence you have assigned the green color to this one. Okay, and this point is look like it is little bit near or closest to C1. Hence you have assigned the red color to this one. Got it? So here you can see that clearly the points which are closer to the red points are assigned to the red cluster. Yeah, the points which are closer to the red point C1 are assigned to the red cluster. Whereas the points which are closer to the green point are assigned to the green cluster. Yes, the points which are closer to this one are assigned to the green point. The points which are closer to the green color or green point, the point which are closer to the green point. So which is my green point? This one. In this image, this is a green point. So the points which is closest or nearest to this green point are assigned to the green cluster. Yeah, these 3 points are closest to the this one, red point. So hence these 3 points are assigned to the red cluster because these 3 points are closest to this C1, whereas these 2 points are closest to the green point. Hence it is assigned to the green cluster C2. C1 is our red cluster, C2 is our green cluster. Got it? Yeah, got it? Now let's see the fourth step. Recompute the centroids of newly formed cluster. Again, we need to recompute the centroids of newly formed cluster. Okay, now once we have assigned all of the points to the either cluster, the next step is to compute the centroid of newly formed clusters. Here, the red and green crosses are the new centroid. Okay, so once we have assigned all of the points to the either cluster, the next step is to compute the centroid of a newly formed cluster. Okay, so it looks like this is a one cluster, this is a second cluster. So here, what we have done, what is the next step? We need to compute the centroid of a newly formed cluster. So here, this one, the red and green crosses are the new centroid. Okay, so let's suppose this is here, the red cross. What is this? It's a new centroid, and this is a new centroid. This is a centroid for this group. This is a centroid for this green point or this cluster, green cluster. Okay. Are you understanding all the steps? First step is choose the number of clusters. So we have chosen 2. After that, you need to randomly select the centroid. So we have selected the 2 centroid that you can see, that C1 and this one, C1 and C2. Yeah, in this image. Here the red and the green circle represent the centroid of this cluster. After that, we need to assign all the points which are closest to the cluster centroid. We need to assign all the points to the closest cluster centroid. Yeah, we need to assign all the points to the closest cluster centroid. Once we have initialized the centroid, we have assigned each point to the closest or nearest cluster centroid. So here you can see this, in this image we have assigned, you can see that the points which are closer to the red points are assigned to the red cluster, whereas the point which are closer to the green point are assigned to the green cluster, right? Is it correct, this one? Now what is the fourth step? The fourth step is we need to recompute the centroid of a newly formed cluster. So this is our newly formed cluster. You can see this one. It's look like a newly formed cluster with the 2 groups. This one, red one, is look like first one, and this one, second one. Now we need to recompute the centroid of a newly formed cluster. Once we have assigned all of the point to the either cluster, the next step is to compute the centroids of a newly formed cluster. So here, let's suppose the red and green crosses are the new centroids. So again, we need to find what is the next step. Obviously, we need to repeat the step 3 and 4. We need to repeat the step 3 and 4. What is the third step? This one. In the third step, assign all the points to the closest cluster centroid. Once we initialize the centroid, we need to assign each point to the closest cluster centroid. So after the fourth step, what is the fifth step says? The fifth step is repeat the step 3 and 4 again. So once we repeat the step 3 and 4 for this one, what is this crosses? The crosses is nothing but here the red and green crosses are the new centroids. So again, we need to calculate which points are closest to this centroid. So obviously, it looks like these 4 points are closest to this centroid, whereas these 4 points are closest to this centroid. Okay, and again, we need to choose some other centroid. Yeah, we need to recompute the centroid of a newly formed cluster. Yeah. So repeat the step 3 and 4. Okay, so we then repeat the step 3 and 4, and then we will get this one. Okay, the 2 clusters. The step of computing the centroid and assigning all the points to the cluster based on their distance from the centroid is a single iteration. Yeah, but wait, when should we stop this process? Yeah, because as per the steps, step 5 is saying us repeat the step 3 and 4. And step 3 is saying assign all the points to the closest cluster centroid. Whereas the step 4 says to recompute the centroid of a newly formed cluster. Okay. The next step is to compute the centroid of a newly formed cluster. So here we can see that the red and green crosses are the new centroid. Once we have this one, we have again performed the third and fourth step. Okay, so when we need to stop it? So it can't run till eternity, right? So see the stopping criteria for k-means clustering. So see, after this one, once you got it, you might be choose to have a new cluster. For example, it is first here and then second one here is. First one is here, second one is here. Okay, wherever it is. Okay. So what is the criteria to stop for k-means clustering? So see here, there are essentially 3 stopping criteria that can be adopted to stop the k-means algorithm. So first one is centroid of a newly formed cluster do not change. Okay. Let's suppose if you apply the third step. Let's suppose, okay, repeat the step 3 and 4. Okay. So once you repeat the step 3 and 4, you're getting this one. This is a first cluster, second cluster. Okay. Again, if you want to have two clusters, okay, what is the step 3? In case of step 3, we are assigning all the points to the closest cluster and centroid. And in case of a step 4, we need to recompute the centroid of a newly formed cluster. So this is our newly formed cluster. So let's suppose again you create a newly formed cluster for this one. Okay. And then again you need to perform the step 3. Yeah. So at what point you should stop this one? So there are essentially 3 stopping criteria that can be adopted to stop the k-means clustering. First one is centroid of a newly formed cluster do not change. Okay. Once you arrive at this situation, at this image with the 2 cluster, again if you repeat the process 3 and 4, okay, and you are getting this image same. So this means the centroid of a newly formed cluster do not change. Okay, that is one of the stopping criteria of k-means clustering. The next one is points remain in a same cluster. Okay, so see, initially this point was associated with the red color. Yeah, if you remember, see this one. When we have chosen 2 centroid randomly, so see this one C1 and C2. We have chosen these 2 centroid. After that, what we have done, we have assigned all the points to the nearest cluster. Okay, so it's look like this one. So this red is look like closest to this one. It's in this cluster. So after that, what we have done, in case of 4th step, we have recomputed the centroid of a newly formed cluster. So here you can see that red cross and green cross are the new centroid. And again, we have performed the 3rd step. After the 4th step, this one, the 5th step says to perform the 3rd step, in which again you need to think, we need to assign all the points which is closest to this cluster and all the points which is closest to this centroid or cluster. Yeah, you need to assign what are the points which are closest to this centroid and what are the points which is closest to this centroid. You need to assign it. Okay, so repeat again. So what is the first criteria to stop k-means clustering? The first one is the centroid of a newly formed cluster do not change. So again, if you're getting the same image, it should not. It is one of the criteria to stop the k-means clustering. What is the next criteria? The points remain in a same cluster. So here, see here, the points are remain in same cluster. If you again proceed with the step 3 and step 4. Okay, so in case of step 4, let's suppose again you recompute the centroid if you choose any other centroid. Okay, and these points are belongs to the same group and these points belongs to the same groups. Then if the points remain in a same cluster, that is one of the criteria to stop the k-means clustering. What is now the third stopping criteria for a k-means clustering is maximum number of iterations are reached. Okay, got it? Are you getting it? Okay, so we can stop the algorithm if the centroid of newly formed clusters are not changing. Are you getting it? We can stop the algorithm if the centroids of a newly formed clusters are not changing. Okay, and the points belong to the this one also, and the points remain in a same cluster. Even after multiple iteration, if you are getting the same centroid for all the clusters, we can say that the algorithm is not learning any new pattern and it is assigned to stop the training. Got it? Yeah. So let's suppose if you apply a newly cluster here, a new cluster on this point, okay, and if you find that the group or the cluster is not changing here, there are 2 clusters, red and green, you can say that centroid of a newly formed clusters are not changing, points remain in the same cluster, maximum number of iterations are reached. Got it? These are the stopping criteria for k-means clustering. So how does the k-mean clustering working? Yeah. So we have seen the example in which we have taken 8 points. First step is to choose the number of clusters. So we have chosen 2. After that, randomly selected, we need to randomly select the centroid. So we have chosen 2 centroids, C1 and C2. Yeah, C1 belongs to the red one and this C2 belongs to the green one. Yeah, here red and green circle represent the centroid of this cluster. Now what is the third step? We need to assign all the points to the closest centroid or the closest cluster centroid. So we have assigned it. And in case of a fourth step, we need to recompute the centroid of a newly formed cluster. Okay, and then again repeat the step 3 and 4. So that once we see that the newly formed cluster are not changing, the centroid of a newly formed cluster do not change, the points remain in the same cluster and the maximum number of iterations are reached, then you can say it's time to stop for a k-means clustering. So we can stop the algorithm if the centroid of a newly formed clusters are not changing. Even after the multiple iteration, we are getting the same centroid for all the cluster. We can say that the algorithm is not learning any new pattern and it is the sign to stop the learning. Got it? So I hope you understand what is the clustering. Yeah, applications of clustering and how does the k-means clustering work. Yeah, with the help of example we have seen that. Now it's time for us to understand k-means clustering algorithm example with the help of Python programming. So I will continue with the next point of how the k-means machine learning algorithm works using the Python programming in our next session. Okay? Yeah.